Hi, in this video, we're going to be talking about describing motion. And our goal for this video is to start to develop some scientific vocabulary in order to properly describe motion. Now, in order to do this, I'm going to give you a couple situations, and we're going to do a little brain dump, meaning the first couple questions, you're just going to dump whatever's on your brain. There's not necessarily a correct or incorrect answer. I just want to see what kind of notions you already have about motion. So let's give it a shot. All right, so if we look here, we can see that the ball is moving. I'm not trying to trick you, but I want you to think about these questions here. So first, what is motion? Like, how do we even know that the ball is moving? So I always think back to a little 2-year-old, right? Who's always asking why or what, right? So how would you describe motion to someone, right? How do you know that the ball is moving? So don't even just say your eyes or your brain tell you. What are your eyes and your brain looking for in order to help you figure out if something's moving? All right, let's look at this situation. It says, if you fall asleep in the car, how can you tell whether or not the car is moving when you open your eyes? So I know for me, whenever I take long road trips, I try to make the time pass by falling asleep. And every time I fall asleep and wake back up, the first thing I always want to know is the car moving, right? Maybe we're at a rest stop or maybe we're still on the road. So what I do is I look out the window, and you probably do this too. Now, in order to tell whether or not the car is moving when you look out the window, what do you look for? All right, and what would you notice? If the car was moving, what would you notice? All right, so again, this is a brain dump. I just want you to start thinking and outlining your ideas here. All right, next, we're going to be talking about the location or position of an object. When I think of finding the location or a position of an object, I think of Where's Waldo, and this is a game that I played growing up. If you've never played Where's Waldo, you actually have a really busy picture, and then you have to look for this guy here. His name's Waldo. I promise Waldo is in the picture, but your next task is to identify the position of Waldo, find Waldo, and then obviously you can't point him out to me. So what I want you to do is create a description to help me find Waldo. Okay. So create a description that would help me be able to find Waldo, or Waldo's we call position. All right, so now that we've outlined these ideas, we can start to tie some scientific vocabulary for probably the big ideas that you've uncovered. So how can we tell if an object's in motion? There's kind of two big ideas here. The first is we can use what's called a frame of reference. Now, you've probably started to uncover the idea of a frame of reference when you were talking about falling asleep in a car. Now, what you can do in order to tell if the car is moving is look out the window and find some objects, okay? And typically, we like to use objects that are not moving. So trees, street signs, houses, right? And when you look out the window, you can try to observe their apparent motion. Now, if it seems like those objects are moving, in your brain, you know that they're really not moving, and that helps you identify, oh, I must be the one moving. However, if you see those objects, right, so the trees, the house, the street signs, right, and they're at rest, right, you probably know that you're not moving. So this system of objects not moving with respect to one another are good indicators of allowing us to compare motion. So we call that a frame of reference. You'll notice we picked things like trees, houses, street signs. You probably could identify so many more. We pick those objects because they're not moving, right? It's easier for us to compare our motion with something that's not moving. Comparing yourself to other cars is probably not a good idea because it's hard to tell, am I the one moving or is that other car moving? So the big idea there is that system of objects that we like to compare motion with, we call a frame of reference. Now I asked you to identify the position or the location of Waldo. This location that we describe in science, we call position. Position is the scientific word for the location of an object. But whenever you give the position of an object, there's actually 3 things that you must always include. First, it's the object's distance and direction from the origin, or we call, like, if you compare that to another object, we call the frame of reference. So think back to the description you wrote for the position of Waldo. Were you helping me identify other objects? You'll actually notice here, right? Here's Waldo. He's next to that ring, right? He's next to the lumberjack and the tree, and he's next to the tennis court here. So these are all objects that you can use as your frame of reference to help describe Waldo's position. You might also give directions, right? You could also say from to the right of the tree or to the left of the tennis court. And that would help me identify Waldo as well. And it's kind of hard on here, but if I really wanted to pinpoint the exact location of Waldo, I would also have to give a distance. So if I was in Waldo's little world here, I might say, 10 meters to the right of the tree, right? You'll notice then I'm starting to include the location by describing my frame of reference, or what I could call an origin. Also, I'm giving the direction and the distance. So that's the big idea. When we start talking about position, you need to include these things. All right, so that brings us back. So what is motion? And I'm going to give you the opportunity to revise your definition a little bit, and then I'll give you my definition. I do want to say that there's not one perfect definition for motion, so just give it a shot. All right, and you can compare your definition to mine. When I think of motion, what I'm looking for is a change in position of an object over time. So over time, if that object's position's changing, right, then I would say that it is in motion. All right, so the next thing to think about is when we start talking about things that are moving, we can ask the question, well, who went farther? And I'm going to show you a little video of The Wizard of Oz. And I always have to show the video because if I try to describe the Wizard of Oz, I actually sound like I'm crazy. So in The Wizard of Oz, there's this girl who's from Kansas, and she ends up in this world, and there's these little munchkins, and they have to follow the yellow brick road in order to find the wizard. And like I said, it makes me sound crazy. So I'm just going to have you watch. So she has to follow the yellow brick road. Here's Dorothy. Her little dog is called Toto. Get out of here. And you can see Dorothy can follow instructions, right? She knows what the yellow brick road is. But take a look at poor Toto. Toto's a dog. Toto doesn't know what the yellow brick road is. And he kind of he's doing a pretty good job, but he's kind of all over the place here. So you get the gist of it, and hopefully you don't think I'm crazy. All right, so let's take a little look here. Let's say I outline the paths of Dorothy and Toto. Let's say Dorothy started here and Toto started here. And Dorothy goes from here to here, while Toto starts here and goes all the way around and ends up here. So my question for you is, who went further? Dorothy or Toto? And I want you to give an answer, and I want you to explain your answer. Why did you choose that person or dog? And it brings up the idea that actually words like farther are actually unclear, and we don't want to use unclear language in science. So I'm going to ask you, why might one argue that Dorothy went further? Why might someone argue that Toto went farther? So think about those different arguments there. All right, so this brings up two new scientific vocabulary words that we'll include. And these things are kind of describing how far someone went, but it pinpoints an actual definition. So further is not clear, but we can describe these two ideas with two definitions. The first being distance. Distance is the length of the entire path between 2 points. Again, go ahead and record this definition on your loose leaf. And the other is the displacement. Displacement is the straight line distance and direction between 2 points. Okay, so I'm going to ask you, who went a farther distance? Did Dorothy or Toto? Now this is a little bit more clear. There's only one correct answer here. Who went a farther distance? Dorothy or Toto? And why? And then who went a who had a greater displacement? Dorothy or Toto, and why? So pick one person or object here, I guess, or Toto. Dorothy or Toto. There's one answer here for each of these, and then defend your answer.